Before we get started, I want to give a shout out to another podcast in the mobility space that I think you'll enjoy, the Rideshare Guy podcast by Harry Campbell. Harry has become a trusted expert on all things rideshare, and he may be the only person ever to have driven for Uber and also interviewed Uber's CEO on a podcast. On the Rideshare Guy podcast, Harry interviews a wide range of industry and thought leaders in the rideshare and mobility space. You can find and subscribe to the Rideshare Guy podcast on Apple Podcasts or wherever you listen to your podcasts. This is Smarter Cars, a podcast about autonomous vehicles and the future of transportation. Welcome to Season 4. This is your host, Michelle Kairouz. In this episode, we talk with Jordan Coleman, General Counsel at autonomous trucking company Kodiak Robotics. We discuss the state of the autonomous trucking industry, safety considerations, and some of the policy and regulatory issues these companies are facing. Jordan, welcome to the show.
Thanks, Michelle. Thanks so much for having me.
Great. For those who don't know, can you start by telling us about Kodiak and what the company's doing?
Yeah, I'd love to take the opportunity. So Kodiak Robotics was founded in April of 2018 with the goal of bringing autonomous technology to the long-haul trucking space. Founded by a guy named Don Burnett, who I like to say has 12 years of experience in a 10-year-old industry. Don's kind of been at the forefront of autonomous technology from the early days. Was at Carnegie Mellon back at the tail end of the DARPA challenges. And then left Carnegie Mellon to join the Google self-driving team in the early days, and worked on that project for a number of years as one of the early software engineers. Left Waymo, what was then the Google self-driving project, to focus specifically on long-haul trucking. The progress in self-driving on the passenger vehicle side, while obviously had made a tremendous amount of progress, Don was of the belief that was still a little ways off. Something I'd say is, as we look at it today, was pretty prescient, and elected instead to leave and co-found a company called Otto. And Wallet Auto helped build a truck that did the first driver-out autonomous delivery of some Budweiser, actually, in Colorado. And then Otto was subsequently acquired by Uber, where Don went on to lead the software effort for all of Uber ATG, both the car project and the truck project. And fast forward to the early part of 2018, where Uber was de-emphasizing its truck program to focus on robo-taxis, which obviously fit its ride-hailing and specific use case. And Don said, I really believe in trucks. I really believe that this is going to be the first commercially viable application of autonomous technology, and we can get into why. And left and said, I think I'm going to start my own thing. At the same time, a good friend of his, a guy by the name of Paz Eshel, who was a venture capitalist at Battery Venture, leading that firm's thesis on autonomous technology, had been looking for the right investment in the space and hadn't necessarily found one that he thought was the perfect fit. And the two of them essentially put their heads together and said, we really believe in this. We think we can do it the right way. And we think that there's an amazing opportunity out there to help society as a whole and build a great business along the way. And so left and started the company. To give a little color on what kind of has taken place since then, again, company was formed in April of 2018. Built a technology team of some of the leading lights in the industry, and raised a $40 million Series A in August of 2018. Subsequently took possession of its first truck in early December, and before Christmas, that truck was doing autonomous loops in the parking lot behind our building. And then following conversations, of course, with regulators, began street testing in the spring of 2019. And very excitingly, in July of this summer, July of 2019, completed its first commercial delivery utilizing its autonomous technology, obviously with a safety driver in the cab at all times, but began commercial operations in July and has subsequently continued to haul freight autonomously with a safety driver in the cab regularly for commercial customers since then, and is now doing so on an effectively daily basis.
So let's talk about the technology that Kodiak is using. Are you starting with an existing truck and then adding a sensor suite and your own software, or how does that work?
Yeah, great question. So we buy off the line trucks directly from the manufacturer. Trucks. What I was kind of amazed having started this company was, you assume that buying a truck is similar to buying a car. There's, a particular make and model. You pick the color, and there you go. But if you actually check your way through all of the options and various things on the truck, it's kind of amazing how much these things are unique and created unique by the manufacturers. But we do buy them effectively off the line and then uplift them, building on not only our own sensors, which is cameras, LiDARs, and radars, but also building in the drive-by-wire systems and the actuation system. So actually actuating the steering column, the brakes, the throttle, and working with some of the tier one providers of those systems to uplift those onto the vehicles as well, upfit those onto the vehicles as well. Then in addition, we of course have our custom built software suite, which we've custom built from the ground up specifically for trucks that we blend with this kind of best of breed hardware technology and the drive-by-wire systems that we help work with and integrate.
Right. And you mentioned the sensor suite, cameras, LiDAR, and radar. Are those kind of off-the-shelf products, or are you developing your own sensors?
No, we work with our sensor providers to identify, test, and pick the best technology for our particular use case. So we use a couple of different LiDARs, radar, and a variety of cameras, and kind of are continually reviewing. This technology is continuing to evolve and mature at a very, very rapid pace, and so we think it's critical to continue to test the newest sensors as they hit the market and select systems that are the best fits for our technology and for our deployment environment.
Right. So some folks say that cameras provide better long-range predictive capabilities than LiDAR. So with trucks on highways going high speed, are there kind of different considerations about how to think about the sensor suite?
I think what's important to think of from a truck perspective is redundancy. We think the best approach is to leverage all these technologies for redundancy purposes, as well as to leverage the different capabilities of the different sensors. When you think about that, let's say on a passenger vehicle specifically, it can sometimes be hard to justify the added expense. When you think about an individual buying a self-driving car, they may balk at adding an additional $10,000, $15,000, $20,000 LiDAR, for example. And that cost point can be prohibitive for individual consumers. However, when you think about it on a truck platform, trucks are built to run 1 million plus miles. And so your ability to leverage the benefits that of the technology and of the specific sensor over the course of that very long life is something that is where you see significant benefit. So you're able to take care of the added safety and redundancy benefits, but you're also able to pay those costs and the specific cost of those sensors over a much longer time horizon.
So are you guys driving the trucks just on the freeway, or are you anticipating going all the way from the freeway to a warehouse?
So our current deployment environment is what we're calling the middle mile. And the way we define that is essentially highway exit to highway off ramp. So on ramp, highway, and off ramp. That is what we think is the sweet spot for initial deployment of this technology. When you think about how this technology has been deployed, particularly on the passenger vehicle side, and particularly the robo-taxi use case, you think of where that can deliver the most value, which is in dense urban environments such as San Francisco, New York City, Chicago, Dallas, and the like. And then if you think about the hardest possible driving environments in order to deploy autonomous technology, it is those dense urban environments. I always take it back to San Francisco, which is where I live. On a San Francisco street, you're going to have cars and buses and pedestrians and bicycles, muni cars, rail cars, dogs and cats. I think I saw a lizard on a leash once. And all of these things, for the most part, are acting in a oftentimes not very predictable manner. Not to throw San Francisco drivers under the proverbial bus or truck, shall we say, but let's say I've seen a couple of people roll a few stop signs, a couple of people not use their blinker signals when they're supposed to, maybe not travel at the appropriate speeds, et cetera, et cetera. And so, again, when you think about that, that is the most complicated environment possible. You contrast that with the highway environment, where, for the most part, you're not going to see things like pedestrians, bicyclists, let alone pets. But you're also going to see vehicles traveling in the same direction at relatively predictable speeds and driving in a relatively predictable fashion. And you come up with an environment that is much more variable constrained. And it makes it a much easier environment to deploy self-driving technology than, say, in a dense urban environment. Now, I should say, when I say that, my engineers say, hey, Jordan, this is really hard. So it's important to note, I didn't say it was easy. I simply said it was easier. And that's a big part and a big fundamental piece to our thesis that self-driving trucks are the first commercially viable application of autonomous technology.
Yeah, it seems like that's generally the thesis. So how do you get from the freeway off-ramp to the warehouse? Does this model kind of envision using human drivers then for the last mile?
It does, which we think is one of the benefits of this model. We foresee driving our trucks to switching facilities or transfer hubs that would be as close to highway adjacent as possible. Switching and having a manual tractor, human-driven tractor, drive the load to that point, at which point it would transfer the trailer from the manual tractor to the autonomous tractor, which is essentially pointed towards the highway. We engage, and the tractor immediately gets on the highway, drives till the highway exit as close to its final destination as possible, pulls off the highway, and again goes directly into one of these transfer hubs, at which point you again will swap the trailer from the autonomous tractor to the manually driven tractor, and a human driver will take it that last mile and handle some of the more complicated places, such as the depot yard, backing the load directly onto the docks and otherwise. And so, again, we feel that this maintains that structured and limited variable environment, which allows this technology to hit the roads sooner. And the reason why we think it's important to get this technology on the roads is the potential safety benefits and the safety promises of this technology, along with reducing congestions on roads, along with reducing carbon emissions, along with providing some economic benefit to shippers and end consumers as well. And so we think it's that suite of benefits that push us to want to pick the most constrained operating environment possible to allow this technology to get out in a safe, fundamentally safe and reliable fashion.
So I think you mentioned you began road testing in the spring of 2019.
Correct.
Where are you testing, and why did you choose those particular places to test?
Sure. So our company was originally founded in Mountain View, California, which is where we have our headquarters and where the large part of our engineering organization resides. And so we, of course, have been testing on roads in the Bay Area, most specifically Highway 280, 101, and 85, which is our kind of initial testing loop. Obviously, let me take a step back, which is before we talk about on-road testing, I think we should talk about all the steps that are taken before we ever put the vehicles on the road. When you think about the genesis of this industry, it was that being self-driving vehicles. It was, let's get a car, let's hack together a solution, and let's put it on the roads and see what happens. Not saying that it was unsafe. That was the tools that were available to the industry in its very, very early days. Luckily, we live in a world now where there's a much broader ecosystem. One of the most important parts of that is the availability of high-quality simulation environments. And that allows us to test our code in a simulated environment in an innumerable number of scenarios. Well, actually, a very specific number of scenarios, hundreds and thousands of scenarios, and allows us to test to ensure that our software behaves the way we expect it to. It is only after we pass through those simulation scenarios that we then put it into what we call structured testing, which is essentially closed course testing to say, okay, this is how the truck reacts in the simulated environment. Let's make sure that's actually how it reacts in the real world. Let's make sure the safety driver who's sitting in the left seat of the cab is comfortable with the way it's driving. It's one thing for it to act a certain way in a simulation, but if the hard braking or the juking or otherwise is something that a driver is not comfortable with, then we should not be taking those actions in the real world. And it's so only after we've kind of ironed things out in simulation, then confirm things in structured testing, only after those two steps do we then take it on the roads. And I just think that's a very fundamentally important thing to not only how Kodiak is approaching this, but how the industry writ large is approaching this problem. And I think it is a fundamentally much safer approach. And so I think it's for the benefit of everyone. That said, there is that third step, which is after you've proved it in simulation and after you've confirmed it on a closed test track, you do need to take it out onto public roads to ensure, again, that you're capturing the appropriate data and that you're seeing the system perform how you expect it to in that direct deployment environment. So again, sorry for that tangent, but I think it was an important part to nail that simulation piece.
Absolutely. And then when you say that you do some driving on California roads, that's not autonomous driving. That's testing sort of at a level 2 type driving.
Correct. As things sit today, we know our friends at the DMV are working on heavy duty regulations, and we're really excited for those to hit the roads. We, of course, have had in-depth conversations with the DMV as well as with the California Highway Patrol regarding our testing activities, which to date are absolutely L2 vehicles that we are testing towards an L4 future. And so right now, effectively, it is adaptive cruise control, it's lane keeping, it's some lane changes, but it is absolutely a level 2 system with a safety operator behind the wheel, hands on the wheel, ready to take control at all times and always actively monitoring the system. And so we also have deployed in Texas as well. That said, again, the system is a level 2 system being progressed towards level 4. And I think that's a very important distinction that you laid out.
Yeah. And so I think, for people who see various trucks on the freeways in California, whether it's Waymo or Kodiak or other folks, that testing is all being done similar to like a Tesla autopilot in terms of the system that's being run there. It's not a fully autonomous truck. So tell us a little bit about what you're doing in Texas. What are the rules in Texas? Are you allowed to test a level 4 vehicle there? And how did you get from sort of road testing into this commercial delivery that you mentioned you started in July of this year?
Yeah, I think another great question. We're really excited about our operations in Texas. We built an office in Texas over the summer. We sent our first truck out to Texas in July and began road testing there in early July. Same systems being tested there. The regulatory environment in Texas is different. There's an explicit Senate bill that was passed that permits both the testing and commercial deployment of autonomous vehicles on Texas roads. That includes both, obviously, as I said, the testing as well as the commercial deployment. The Texas law does not make the distinction between level 2 and level 4 systems. And so there is what we think of as a Kodiak and industry friendly regulatory environment that's going to allow us to continue to progress this technology while doing so fundamentally safely. We began with road testing. That involves not only, again, confirming what we have seen in our testing in California and that it will react in similar ways in Texas, but part of this technology also is data collection and mapping, and the roads in Texas, while again being in constrained highway environments, of course, have their own unique variables. And so it was important for us to get out there and drive those roads manually for mapping and data collection purposes, and then to begin our autonomous testing on those roads as well. And it was only after we kind of built our system up and burned our system in that we then began to move freight commercially for customers. Now, Yes, we are moving freight for customers, and yes, we are doing so and being paid at a market rate. But of course, all of our activities, as they sit today, also do remain testing operations. We are continuing to learn about our system, continuing to improve our system, and continuing to improve the functionality and features of our system, all while being able to haul freight. And when you think about this, I think again goes to the unique nature of trucks, which is these trucks need to be tested where it's just the tractor without the trailer attached. We need it to be tested with the trailer attached, but the trailer empty, the trailer partially full, and the trailer full, and with various weights in the trailer as well. And so, what a great opportunity to work with our commercial partners for them to learn more about this technology, the promises and the benefits of this technology, while also allowing us to minimize our time on the roads, right? We could drive a trailer that we've loaded full of sand to learn things, but considering that goods need to get from Dallas to Houston, back from Houston to Dallas, and our trucks will be driving on that route, the opportunity to both advance our system and deliver freight and build relationships and build logistics DNA with our customers and with our partners, we think is a unique and exciting opportunity, and one that we're really thrilled to have.
Yeah, that's great. So is the route generally Dallas to Houston? I guess Texas is a big state or country, depending on who you ask. So
Absolutely.
is that where you're testing mostly?
Yes, our initial lane is Dallas to Houston, obviously, and back. Obviously, Texas is an extremely freight-rich environment, and I think it's important to think about the reasons why we did go to Texas. When you think about what you are looking for in an ideal deployment environment, you first want to make sure that it is a freight-rich environment, and Texas is enormously freight-rich. The amount of goods that begin and end in Texas alone, the intrastate commerce is enormous, and obviously the amount of goods that either come in out of state or that begin in the state and then leave state, it's an enormous freight economy, and so we had that. Secondly, you're looking for a robust infrastructure, and Texas has one of the best highway infrastructures in the country. We've developed really strong relationships with our partners at Texas Department of Transportation, the Department of Public Safety, as well as the governor's office and the legislature, and they're big believers in the promises of technology, and are very committed to building and maintaining very safe roadways, and that infrastructure is something that our trucks can absolutely leverage. You're also always looking for the right regulatory environment, which we touched on earlier, and we think that there is an ideal regulatory situation. Again, a very involved legislature, a very involved governor's office, Department of Transportation, and DPS, people that we meet with regularly, and that they share their concerns with us, and we share our feedback with them. It's a very good iterative process and a very good relationship with them. And then finally, you're looking for what I would call is relatively stable weather. This technology will be rolled out in stages. And as things sit today, we can handle light and moderate rain. We can handle night driving. And maybe this is partially because I'm a lawyer, but I am not pressing for us to be in deep snow and mountain passes near Tahoe and black ice anytime soon. And I think it's important for us to nail the technology in these more structured environments and in these more weather predictable environments first, and then continue to progress the technology from there.
Great. So you're able to operate in rain and also at nighttime. Are there any other operational design domain constraints other than, the route and the weather and the light that you, I guess, have covered?
No, yeah, I mean, I think it's road type, right? Again, we are constraining our deployment to the highway settings. It is, specifically geofence. So we pick the routes, we pre-plan, we pre-map, we pre-drive those routes in manual, and prepare our vehicles to drive those in autonomous mode. And then again, ensuring that our vehicle is tested and validated in different weather environments. And so again, we are, as things sit today, obviously ideal weather, we're good to go. We drive at night and we drive in light to moderate rain, and we will continue to focus on growing that ODD over time. But as things sit today, we're trying to nail that initial deployment environment first. And improve the features and functionalities of our system, and then we'll look to continue to grow our system and grow its deployment environment as the technology continues to progress.
Let's talk about some of the policy and regulatory hurdles. We've covered a few, but one of the big categories of opposition seems to be around the question of jobs and the impact on the economy. There seems to be opposition from the Teamsters Union and others saying millions of jobs will be lost to automation. And I know on the trucking company side, they usually say there's a shortage of drivers, not going to put people out of work. How should we be thinking about this issue as we move forward into autonomous trucking?
Yeah, Michelle, I'm glad you asked that question. I think, workforce impact is obviously something that's top of mind for legislators and regulators, for the labor itself, as well as for us as a company. It's something that we take very seriously. I think, firstly, is to point out that in 2018, the ATA estimated that the driver shortage was a little bit over 60,000 drivers. Additionally, the average age of long-haul truckers is estimated to be in the mid-50s, and 6 or 7 years ago, that was estimated to be in the late 40s. And so you're seeing an aging population. That said, I think our deployment model is also critical in this. We view truck drivers as an extremely skilled profession. And again, it's talking about those difficult environments that they need to drive these trucks in. Again, imagine driving a Class 8 semi-truck in downtown San Francisco. That's a very difficult environment to be in. As I mentioned, some of the depot centers, yards, a lot of variables. These are tough and skilled jobs. And so our deployment environment of the middle mile and focusing on-ramp, highway, off-ramp, again, in that constrained environment, it keeps those most highly skilled pieces of that job to human truck drivers. And so, again, we feel, if anything, that we'll be backfilling that driver shortage over time. And again, I think as things sit today, if you took every autonomous trucking company combined and talked about the number of autonomous vehicles, again, testing towards level 4 autonomous vehicles they have on the road, I think you'd be talking about tens of vehicles combined across the industry. I doubt you'd even get to 100, add it all up together. And so when you think about a 60,000 plus driver shortage with less than 100 total autonomous vehicles across the industry on the road, I think you see that it will take quite a bit of time for the technology to even start eating into that driver shortage, let alone impacting job number one. And then again, in speaking to that constrained operating environment and our deployment model, it keeps those first and last mile jobs, the most highly skilled jobs, and in a lot of ways, the most highly sought after jobs. We talked about the aging workforce population. Part of that goes into, younger people are not necessarily looking for jobs that can keep them on the road and away from their family for days and weeks at a time. And so this allows an actual increase in those first and last mile jobs, and allows people to work a full day and be home, be it for dinner, be it for basketball game or piano recital. And so we're a big believer in the potential promise of this deployment model and the way that it's going to integrate and work well with labor and address some of labor's concerns.
And how do you look at the demand for trucking overall? I mean, we see this shortage today, and I feel like the number of Amazon deliveries keeps going up. Is the industry of the view that the demand for trucking overall is going to increase at an even greater rate than it has, in the last 20 years? Or how do you think about that as an industry?
I think it's an important point, which is, the continuing growth of e-commerce is only going to drive an increased need for trucks and an increased need to move freight. I don't know about you, but I get a lot of Amazon packages to my house. I have 2 young daughters and I have another child on the way, and I think that the need for bottles and binkies and things and diapers will only increase in my household in the short term. And a lot of those are being shipped to me by Amazon. But again, be it an increased number of e-commerce deliveries, increase in the amount of groceries that are being shipped, and otherwise, there's so much freight in this country that needs to move. Right? It was estimated that trucking was an $800 billion industry, approximately. I think it was 796 specifically, and expected to grow north of $1 trillion in early 2020s. And so I think that underscores the continuing growth of this market and the continuing need. So not only do we have that driver shortage today, I do agree with you. I think that will continue to increase. driven in part by the increased continued growth of e-commerce and other shipping needs.
Yeah. So when you think about freeways and trucks driving down the freeway at 60 plus miles per hour, it sounds great to have autonomous trucks, but it does make you think, how safe are the trucks and what are the rules that are actually governing the industry? So can you start by telling us, maybe at the federal level, you've talked a little bit about kind of the difference between Texas and California, but maybe backing up, if you could talk a little bit at the federal level, how are trucks regulated? Who are your regulators, and kind of where do things stand for autonomous trucking with each of those regulators?
Yeah, I'd love to. And actually, if it's okay with you, Michelle, I'd love to take a step back and talk about safety on a high level very quickly. Safety is, as I mentioned at the onset, is one of the true North Stars and true guiding lights for this company, why it was founded and why we believe this technology should be deployed. But it's also very important to note, as you mentioned, it's 80,000-pound trucks. And what I like to say is that there's no such thing as a fender bender when an 80,000-pound truck's involved. A lot of force, a lot of mass traveling down the roadways. And so doing things fundamentally safely is absolutely critical, not only for Kodiak, but for the industry as a whole. It's something that we is talked about ad nauseum at this company, and I hope it cannot be talked about enough. Doing things fundamentally safely, be it from a top-down systems engineering approach, where we are building in safety into actually how we design these vehicles, to rigorous, as I mentioned, rigorous, heavy use of simulation and rigorous testing before these things are ever hit the road, but also building that culture of safety. Having buy-in on from safety and true belief about safety on the hardware side, on the software side, on the trucking operations side, everywhere. Right? Our finance people talk about safety. Our HR people talk about safety. It is truly a deep and well-held belief in this company, and something that I'm really proud of what we are doing. And so, I often get the question of what keeps you up at night. I love to say I have two young children. My wife's pregnant. I'm a lawyer, so everything keeps me up at night. But it is, other than the family things, it really is that first autonomous truck crash. And I do say autonomous truck crash, not Kodiak autonomous truck crash, because when that truck crash happens, there's going to be increased focus and increased scrutiny and increased questions. And so I think unless you are building a fundamentally safe product from day one, and unless you are building relationships and proving to people that you're doing things safely from day one, you can't be caught flat-footed when that occurs. And so, that's been a fundamental to how we've built our policy, our government relations, our regulatory work, is to build those relationships, help people understand what it is we're doing and how it is that we are doing it, and doing it fundamentally safely. So that's kind of step one. And that's been critical to me in meetings in California, meetings in Texas, meetings on Capitol Hill, and everywhere in between, is making sure that we are communicating the importance of safety and communicating how it is that we are focused on that at Kodiak. So I just wanted to give that background, because I think, again, no one can talk about safety enough. I think it should be the thing that is the first thing out of people's mouths and the last thing out of people's mouths when they're talking about deploying autonomous 80,000-pound trucks. And again, something that I feel very blessed to work at a company where that's the case day in and day out.
Yeah. So, the concern about safety is that we currently don't have federal motor vehicle safety standards that specifically address autonomous driving systems, whether that is in a truck or a car. There sort of isn't a rule at the federal level to address the brains of the system, what they call the automated driving system. How do you think about that? How do you try to measure yourself as a company when there isn't a specific safety standard that's been issued by a regulator at the federal level?
Yeah, I think it's a great question. And it's been something that's been foundational to how we've approached things, which is to reach out and discuss and build relationships with the U.S. Department of Transportation, both the FMCSA, which we can talk about, which regulates the safe operation of the vehicles, as well as with NHTSA, which operates the safe components in the safe manufacturing of these vehicles. To your question about rules around ADSs, one thing that I think has been a great approach that the Department of Transportation has taken to date is understanding that this technology is continuing to evolve at a very rapid pace, and making sure that it's building rules and building regulations that are technology neutral, fundamentally, and also making sure to solicit the opinions of the industry about how these rules need to be created and should be influenced, but also making sure to take all key stakeholders' voices into account, be that labor, be that the OEMs, the manufacturers of trucks, be that owner-operators, be that other labor groups, be that safety groups. They've truly taken a Big Ten approach and said, we want to hear from every stakeholder in this market so that we can aggregate that information and make an informed decision about how to build those regulations and how to set those rules. And I think that's been a welcome process, and one that Kodiak has been very excited to be able to participate in. In terms of your question, again, I think that the technology continues to evolve very, very quickly. So, and it's always one of the risks with regulation is that technological advancement sometimes can far outstrip how quickly regulations can change to capture those advancements. And so I think the U.S. Department of Transportation has done a great job of putting out policy and guidelines to guide ADS developers into understanding and building safety in from the ground and from day one, and making sure that ADS developers are prioritizing that.
Yeah, it seems like, the Department of Transportation has put out this sort of autonomous vehicle guidance, and we had 3.0 was the third version that came out, I think, last year. And, they've taken a lot of criticism from some safety advocates who say, well, gee, how come you haven't come out with any specific kind of mandatory actual regulations? Why are you just doing this voluntary, general guidance? But I look at it and I say, gosh, if you sat down today to try to write that as a specific rule, I'm not sure regulators even know what to write at this point. Like given how fast things are changing. Is that something you guys think about? Like how would the rule be written if someone were trying to sit down today to do it?
Well, I think that what's great is that both NHTSA and FMCSA have engaged in the rulemaking process and started it with an ANPRM, which is an announcement of a proposed rulemaking, and have solicited feedback. And they've definitely given, and if you read those documents and you read the ANPRM, they've very much gotten in the weeds about how these things are going to be deployed and how these things are going to be deployed safely. They want feedback from all stakeholders, and that's open to the public as well. And then in aggregating that feedback, they will then draft an NPRM or a notice of proposed rulemaking. And then at that point, that public comment process will occur again. And I think FMCSA and NHTSA are taking the approach of aggregating as much information as possible to make as an informed of a decision as they possibly can, and to build a rulemaking process that is not outdated the day that it comes out, but is something that can continue to live, and a framework that can continue to live as this technology continues to evolve. I think it's fundamentally the right approach, and one that I think takes all points of view into account, which is critical.
Yeah, I mean, just listening to you talk about the process and the number of steps and rulemaking and then submission of comments and all these things, you can see that inherently, if the regulators are going to take into account all of these points of view, that it takes some time. And so it doesn't seem like something that can just be done, in a short period of time, especially as the industry keeps evolving and the technology keeps evolving, as they're doing it. It's sort of a moving target.
I think that's right, and that's why I think that the kind of Big Ten and informed point of view that the U.S. Department of Transportation is taking is absolutely the right one, and I think that they've been a great partner and somebody who's listening to everyone's point of view and taking all those points of view into account, and are absolutely focused on both the big picture issue as well as the things in the weeds. And I think that's the critical thing to make sure that these rules are written correctly, which is to think about this from the 10,000 foot point of view, but also think about it from how things are going to play out in the weeds as well. And so I laud them for their efforts to date. I think the other point you raise, which is, without those FMVSSs in place, like what else can you look to? And I think, one thing that we think is important is to look to industries that have tackled similar issues before, such as the automotive industry and the aerospace industry. Those are places where, again, you're talking about, big balls of metal that travel at really fast speeds and that have fundamental safety issues and safety requirements. And we look to those industries and learn from the lessons that they can teach us in terms of how to build things fundamentally safely from the beginning. At Kodiak, it's critical for us that we're not trying to build a flashy demo. We're not building a science project. We're trying to build a product. And I think building in that safety and building in that platform for safety from the beginning and leveraging systems engineering approaches and safety standards that have been utilized by automotive industry and utilized by the aerospace industry, it gives us a very solid foundation of not only being able to build something safely, but being able to verify and validate its safety, which is really the critical thing. It's not only to prove, hey, look, it drove down the road and it drove down the road safely today. You need to prove that it's going to drive down the road safely every day and in a variety of conditions. And I really think it's that verification and validation work that's been going on at this company from day one that is fundamentally critical to being able to deploy this technology and deploy it safely.
Yeah, so it sounds like the industry is going to keep engaging in the types of processes that you've talked about in developing the technology in the vehicles. And NHTSA is going to go down the road simultaneously of, interacting with the industry and all the stakeholders and really trying to develop over time an approach that will result in some regulations. There is an interplay there between the federal rules and what goes on at the state level. So without a specific regulation, what they call a federal motor vehicle safety standard governing the automated driving system at the federal level, then it seems that each state is not preempted in that area from regulating autonomous vehicles. So that's why we see, different rules in California or in Texas or in other states. How do you think about it in trucking? Obviously, long haul trucking often crosses state lines. How important is it to you to get, a single federal rule governing the autonomous technology versus going state by state and kind of having different rules in each state?
I think fundamentally for us, it's making sure to work well with all of the partners, all of the state, federal, local, municipal government agencies that we work with. And so, as things sit today, we're deployed in California and Texas. And so we, of course, make sure that we comply with all of the regulatory requirements and legal requirements in both states, as well as making sure that we comply, of course, with the federal standards that are in place, both at the FMCSA level and the NHTSA level. And so for us, it's instead of focusing on what may be, we focus on what the current environment it is, and we make sure that we comply with the rules as they sit and continue to engage with our partners at the federal, state, local, municipal level about continuing to build out rules that make sense for not only the autonomous truck companies and Kodiak in particular, but also that makes sense for motorists as a whole, and for those states and those municipalities and the like. We want to work with people to create rules and regulations that make sense and that protect everyone, but also allow for the deployment of this technology and don't create unreasonable burdens that are not necessary to protect public interest.
So you mentioned the Federal Motor Carrier Safety Administration earlier. So in addition to being regulated by NHTSA, you do have your carrier operations in trucking with a separate regulator. Can you talk a little bit about the approach that the FMCSA has taken to autonomous trucking operations? Maybe you could give some examples of the types of rules that trucking companies have to live by under the FMCSA regulations.
Yeah, that's the unique aspect of deploying trucks or buses, which also fall under the FMCSA guidelines, which is not only about the safe manufacture of these vehicles, but the safe operation of these vehicles. And to your point about some of the inherent interstate commerce nature of trucks, the FMCSA is there to ensure the safe operation of those vehicles. And again, a partner that we work very close with and that we listen to very carefully and very closely. From a rules perspective, one of the biggest ones that's been in the news over the course of the last few years has been hours of service limitations. There are specific rules on the books regarding the maximum number of hours that any driver can work and that any driver can drive. It's 14 hours of a total workday and 11 hours of driving within that day, as well as certain rest periods and otherwise. And as part of the Obama administration, they'd ruled out what are called ELDs, which are essentially electronic monitors for those hours of service regulations. And so that's where you see, the idea there is that drowsy driving can be very dangerous. And so it's important, and that's where the public policy consideration came in from the FMCSA and was to say, hey, we're going to set rules that make sense, that ensure these big vehicles are being operated fundamentally safely. As things sit today, we have a safety driver in the cab. So we have a human driver sitting there. We have a driver with his hands on the steering wheel. And so that driver is, of course, subject to those rules, and we take those rules very, very seriously and take our hours of service limitations very seriously. Obviously, one of the exciting promises of this technology is that, unlike a human being, software does not get tired. Software does not get distracted or drowsy. And so software is going to be able to drive these trucks safely, potentially at in excess of those 11 hours of service, and they can drive essentially 24/7, which that asset utilization, being able to use that truck, upwards of 24 hours a day, I think is one of the very exciting things. But again, as things sit today, and as we have a driver in the cab, we take our hours of service requirements and limitations very, very seriously and comply with those rules.
Great. So final set of questions here. Tell us a little bit about Kodiak as a company. How many employees do you have, and what does the next year or two look like for you in terms of goals and growth?
Absolutely. It's an exciting time at Kodiak. When I joined this company in December of last year, we were a little bit north of 20 employees. And as we sit today, we are north of 80 employees, which has been an exciting amount of growth. What I think's been amazing is we've maintained a really high bar for those that we hire, and we've been lucky enough to be able to recruit, attract, and retain some amazing talent. And so I think it is that team that really sets Kodiak apart as a special place and a company that's going to be able to tackle this challenge and take it head on. And so that's something that's very exciting. In terms of what the next couple of years hold, we're obviously going to continue to grow and progress our technology, continue to build out the features and functionality and the safety aspects, as well as to be able to prove the safety case that we've kind of mentioned earlier, and then continuing to build the business side as well. One of the things that separates Kodiak from some others in the space is that we plan to be a carrier of goods. We are not building this technology to test it and then to license it, to be it to OEM partners, be it to sell these trucks to other carriers. We think it's important to actually carry these goods. We think particularly as this technology continues to evolve, there's an amazing benefit to being able to run your own trucks from a safety perspective, as well as from a revenue generation perspective. And so continuing to build up that logistics DNA and working with our shipper customers to continue to move freight is something that we're very excited to do over the course of the next couple of years. And we think the nice thing is our technology development will help inform our commercial operations, and our commercial operations will help inform what features and what functionalities and where we need to focus our technical efforts. And so we really think that there's an exciting harmony and exciting synergies between those two sides of our business. And we look forward to building up both the technical effort as well as the business effort.
Well, terrific. Thanks so much for coming on the podcast today. I really appreciate you taking the time. It was a great conversation.
Thank you, Michelle. I really appreciate it.
Thanks again to Jordan for joining us. If you're enjoying the podcast, please subscribe on Apple Podcasts or wherever you listen to your podcasts and leave us a review. You can find the show notes for this episode and all of our episodes on our Medium publication called Smarter Cars. Thanks for listening. We'll see you next time.